some nice improvements to IPR inside of Maya 2008. The default render quality goes to your render settings now, and we also get a snapshot when we click the IPR button. So after the snapshot's done, I can select a region to begin tuning, and Maya will start filling in those buckets with first the final gather pass and then the more refined ray trace pass. Now, my render looks pretty good right off the bat, and the reason that is because we're using the physical sun-sky system to generate our lighting model. So what that does is it gives me a sunlight, and based on the angle of that sunlight, we have a procedurally generated environment for. So if I get the sun obviously low and behind here, we're going to get this kind of notion of the sun in the sky here. We get this nice backlit look to my scene, and then obviously as I rotate this light around, the environment changes based on its angle. So it gives you the ability to really in a single mouse click get a very photorealistic looking render for an outside scene. So a couple of other things that have been improved inside of Maya's 2008 rendering workflow is the MIA materials had some nice enhancements made to it. So the architectural and design material, or the MIA material, was new in version 8.5 of Maya, and we now have an extended version of that that adds a couple of new features on top of the already existing workflow. So if we zoom in on our nose of our vehicle here, and we'll get kind of nice and close to this guy, what we want to do is we want to start to make a couple of tweaks or modifications to the material associated with both the nose of the vehicle and the railroad track. So we'll get this kind of zoomed in here. So you'll notice that on this car we have a very hard edge here. So I want to soften the effect of this up. I want to actually add a fillet onto this edge of geometry. And instead of doing that as a modeling procedure, I'm going to use the round corners texture map to do that. So it actually uses a bump mapping technique to go ahead and introduce fillets onto hard edges. So we'll swipe the region we want to tune, which is just the nose of this vehicle here. I'm going to go ahead and turn the anti-aliasing up inside of that to a minimum value of 0. So we get a little more refined draw on the top of that object there, and we'll just graph the material associated with this vehicle. And you'll notice that it is an MIA material. So the MIA material is really your go-to material for anything that's a hard surface. So something like a wood or metal or a glass, the MIA material has all the functionality that you need to represent those surfaces really fast in a very elegant manner. It does some great things like loss of reflections. It has the ability to do glancing angles like BR, DF, refractions. It has different lighting models, so if you want to have non-circular highlights, you have the ability to start introducing micro facets to your highlights to have sort of anisotropic highlights. So it's a very flexible shader. It's sort of like a Swiss Army knife material. There's some presets associated with this to get you started. So again, it does things like brushed metals, really fast glasses, very, very elegantly. So what we want to do in this example is let's just, first of all, let's turn down the reflectivity of the surface a little bit here. Let's just get that a little less reflective. And I'm going to go ahead and jump into the bump map section. And this has been changed a little bit in Maya 2008. We now have two different bump maps. We have an overall bump and a standard bump. So what overall bump does is it bumps both diffuse and specular at the same time. So this is where you'd want to go ahead and put the round corners material. Standard bump has the ability to have the diffuse bump not happen. So what this means is if you're trying to do something that looks like it has a layer of varnish on top of it and there's imperfections on the varnish, the standard bump workflow gives you the flexibility of saying only bump the specularity, don't bump the diffuse. So for things like a varnished wood floor as an example where you'd want to have that the underlying wood wouldn't have imperfections in it, and then on top of that wood would be a varnish that maybe has some ripple or some wave to it, and only the ripple or wave happens on the varnish. So in this case, we want to go ahead and use the overall bump to add in our round corners shader, or actually texture map. So we'll go ahead and we'll go add that round corners onto that guy. So you can see the edge is very harsh here. We'll just save a snapshot of this so that we can jump between those. And if I put my value up to maybe 0.1, you can see that we now have this nice filleted edge happening along here. So it softens that edge. So this, again, allows you to model things with hard edges. So say you have 200 bolts on an engine. You don't want to have to fillet every single bolt. It's nice to be able to do that in the rendering process. Also notice that the wheels are rendering as round objects, even though in my display here they're very they're six-sided. That's happening because we're using mental rays subdivision to tessellate that in the rendering process, which we set up in the previous demo. So a couple of other things that I want to talk about. The round corners material was new in version 8.5 of Maya, and it only worked with mental ray materials. Now inside of Maya 2008, we have the ability to use the round corners on any of the shaders inside of Maya. So if we graph the material associated with the railroad track here, we'll just zoom in on that guy and refine its draw a little bit. I'll add to my selection here, and we'll graph both of these materials. So now we have the MIA material, the mental ray material, and this is just a standard Maya blend. So what we want to do is we want to have this round corners actually bump my railroad track. I want to have little fillets between these hard edges on that railroad track. So we're going to break the connection of that original Maya bump node. We can save that guy just so we can jump between those, and we'll drag and drop the MIA material onto that. And that radius is a little bit big for this railroad track, so we'll go 0.05 on that guy. That's still a little big. 0.02. There we go. So we just have a nice little highlight happening there because we've rounded that guy. Notice that there's something called bump vector. This is also a new feature inside of Maya 2008. We now have the ability to layer on top of the round corners another bump node. So we'll just go ahead and we'll grab the Maya bump node, plop that guy in there so we get the introduction of those little pop marks layered on top of the round corners. So the next thing that we're going to talk about is the ambient occlusion model that's built into the MIA material. So what we want to do is we want to zoom in on this sort of odd little engine detail underneath the nose of that vehicle. So we'll just kind of frame in on our shot here nice and close. That looks pretty good. We'll just select a region that we want to begin fine tuning, and we'll jump the anti-aliasing up to a minimum level of 0. So you can see that we actually have a little bit of ambient occlusion happening on both the blue material and sort of the white material here. So we'll graph both of these guys. So we've got this little ambient occlusion happening right here, and if we want to make these little extenders that are coming out of this engine look like they're glowing, we're going to use a new texture map feature inside of Mental Ray that allows us to add additional color. So if we go to the Advanced tab for that material and we see the additional color slot here, we're going to texture map that with the MIA light surface. So this allows you to generate objects that look like they're self-illuminating. So if you wanted to have a very accurate light bulb, you could model the light bulb and maybe use the MIA light surface for the filament of the light bulb. You have the ability to adjust whether or not that texture or that kind of additional light is going to contribute to final gather and contribute to reflections. And in this case, we don't really care about having to contribute to final gather because I don't want it to overall brighten my scene. I just want it to kind of glow just where those little objects are. So we'll go ahead and we'll increase the intensity of that. And you can see that it's self-glowing now, but we get this sort of a little weird effect where we have this occlusion model happening on the blue shaft, and even though these objects are glowing, you wouldn't expect to have that occlusion model happen there. So what we're going to do is we're going to go back onto the blue shaft shader, and we're going to look at what's going on with its ambient occlusion. We now have a new option called with color bleed. So what this does is it allows the occlusion model to not just go to dark. It will actually look to the neighboring surfaces and use that in its calculation of, instead of just adding maybe gray, it's going to actually go ahead and add a little bit of white in there. So we'll say with color bleed, we have a really bright surface next to it, so that occlusion model is now actually going to go ahead and get white. So it gives you a very nice, realistic looking sort of almost glow effect happening on that engine, which is pretty slick. So we can zoom out one more time here. And let's just refresh our whole scene and see the end result of what this looks like. Actually, let's get over here a little bit more so we can see that engine glowing. So the next thing that we want to talk about is some enhancements that have been made for interior lighting. So the physical sun sky system does a great job when you're outside. It's really primarily using final gather to calculate and capture all the information of what's going on with this environment and get this really nice looking lighting model for us. But it kind of fell apart when you tried to use it on an interior shot. So let's go ahead and check that out now. So if we jump back to our master layer, you can see that I have a garage hanging out over here. So what we want to do is we want to get inside of that garage and start to render the effect of the light spilling into that environment. So there's only one open wall on this object here. So if we jump to our start frame here, you can see my light's kind of streaming in from this side. And if we go ahead and we do a render of this, actually, let's not render the master layer. Let's render the final gather layer for that guy. So when we render this out, we're using Final Gather. The physical sun sky system lives in our scene. So Final Gather is going to go out and try to sample that exterior. And it's a little dark, so we'll go ahead and we'll change the tone mapper quickly. We'll just save this image and we'll grab the tone mapper on this camera. And we'll just put the gain up to a value of 0.5. So we're just turning up the brightness in our scene here. So Final Gather is going to be used to try to transport the light energy that lives outside of the scene into the interior volume. And you can see that it kind of breaks apart. It doesn't really do a great job of capturing the light spilling into this. Final Gather does really well when it's kind of an evenly lit environment. But if it's a very high contrast environment, Final Gather sort of gets very splotchy looking really quick. So you'd have to turn your Final Gather arrays up extremely high so that enough of them make it outside to kind of smoothly transfer that energy into the scene. So if I go ahead and we'll save this really quickly here. We'll jump over to my channel box. And this is what Final Gather is actually seeing. So we'll render this guy out here. This is what happens when Final Gather is turned off. So this is just the direct illumination in my scene. So obviously the physical sun sky is outside. It's high dynamic range. It's very bright. We have a little bit of direct illumination coming in and hitting the ground here. So all this other shading that happens on the back side of this is basically coming along from Final Gather rays, making it out this window or making it to this direct illuminated spot on the floor and using that to add a little bit of additional light or secondary light into the scene. So it looks very splotchy when we have low Final Gather rays. Also notice the effect of this column. This column's actually embedded into that wall, but you don't get any sense of that. You don't get any shadowing or anything. So we'd have to, again, turn the Final Gather rays up to like 500, 600 to make this start to look nice and realistic, which gets very slow. So what we've done is we've introduced something called porthole lights. So what they allow you to do is they allow you to position area lights in the open windows and have those area lights sample the environment and turn what they see as far as the outside world into a direct light model. So we're going to go ahead and we're going to do that now. So we'll jump over to a porthole scene. We'll expand this out to position our area light for ourselves. So we'll just say light, create area light. And where is that guy? We'll delete that area light. When we create the area light here, I don't want to have it set to auto position, so we'll turn that off. Oops. There we go. So we have this area light in our scene, and what we want to do is we want to get it pointing into our building as opposed to out of our building. So we'll just rotate that guy around. And we'll scale it and position it properly so that it fills this open doorway. So now we have that area light positioned properly in our doorway. So this is just kind of a standard area light right now. There's really nothing special about it. So what we want to do is we want to turn this area light into a porthole light. So if we bring up the attributes for the area light here, and the first thing that we're going to do is we're going to tell it to use a mental ray area light shape, and we're going to turn it to visible, which is very important. We'll go over to the light shader, and we're going to pipe into that a new porthole light. And I'm going to use this porthole light actually as a photon emitter also. So the nice thing that this porthole light does is it basically just goes ahead, and what's happening is it's going to block the Final Gather rays. So the Final Gather rays are in the interior shot of this building are actually never even going to escape, because when they hit the area light, they're just basically going to die. And what the area light does is it takes everything that lives on the outside of it, samples it and turns it into a direct illumination model. So it's going to automatically set the color of the light properly. It's going to automatically set the intensity of photons properly and the color of the photons properly. So it really is just a giant sampler of the exterior world, and it takes all that information and turns it into a direct illumination model. A direct light, just an area light that's colored properly and the photons come out properly. So we'll jump back to our start view. We'll jump over to our Hypershade render view here, and let's go ahead and render out the effect of this with the portal light. So it'll take just a few seconds to render through here. So the final gather pass happens, and then the more refined ray trace pass happens. So the look is pretty drastic. The difference between that and that is substantial. Things to really notice are, look at how grounded this pole is here and this nice shadowing that's happening. So this is all basically just direct illumination coming in from this area light, and then there's some final gather stuff that's kind of bouncing this direct illumination model around. So you'll notice that we get an extra bounce up here for free because this whole interior space is now flooded with direct illumination, and then there's some final gather that's kind of bouncing that around and giving us some added effect up here in the roof where that obviously that area light doesn't exist. So the differences between the two are pretty substantial. So a couple of other things that the area light allows us to do that are pretty slick. If we go ahead and we bring up the attributes for this camera, and we go and go to that tone mapper that's on top of this guy, and we'll just crank that up to like a value of 0.9. So I'm really going to blow this out. We'll save this image here, and we can re-render this guy. So this starts to fall apart a little bit, like that exterior is starting to get a little bit too bright. So if we go to the area light, you'll notice that on the porthole light, we have something called transparency. So if I start to drop that transparency down a little bit, what happens is it's actually going to lessen the effect of the outside. So it's going to be like the light is going to not be quite as bright on the outside of that porthole light now. So we'll re-render that one more time. So you can see that it kind of tones that down a little bit so that I'm not losing some of the detail on that exterior of that building that lives on the outside there. So to finish off this demo, we're going to go ahead and talk about a couple of improvements that have been made to the lens shaders in Maya 2008. For all of our previous renders, we've been using the MIA Exposure Simple, which is just a basic tone mapper to help us deal with the high dynamic range images that the physical sun-sky system generates. So it just kind of steps them down into a range that's easily viewable on a computer monitor. And what we want to do is, instead of using this Exposure Simple, is implement the new MIA photographic tone mapper. So we'll break this connection and we'll just go ahead and we'll map to this the exposure photographic. Also notice that we have a new lens shader for dealing with depth of field. This one gives you really nice camera artifacts. So we'll go ahead and we'll map that photographic tone mapper onto our render. And what we're going to do is, instead of rendering this image and then tone mapping it over and over again, we're going to go ahead and load a preview image. So what this does is it lets us render out one EXR file, then load that EXR file in, and then only do the rendering process or the tone mapping process. So we're not actually calculating the geometry when we use the preview image. So it's a nice way of getting very fast interaction with the tone mapper when you're trying to tweak or tune your render. So we'll go ahead and we'll say use a preview texture map. We'll map to that guy just an EXR file that I have out on disk, which is basically this exact same image here. And if we jump back to that tone mapper, we'll just say use preview, and now we'll just do an IPR render. So it does that IPR snapshot, the same thing that it did in our previous demo. We'll select the region we want to begin tuning. In this example, we tune it and everything looks black. So let's just turn up the factor here to something about 1,000. So now we're starting to see something. So this allows us to use very, attributes that you're used to seeing on any camera. So what's your film speed? How big is your f-stop? So if we increase the sensitivity of the film to maybe say 1600, my image gets a little bit brighter. If I want to lift the blacks or crush the blacks or lift the highlights, I can go ahead and start to do that. So if I say burn highlights, start to crank that guy up, you'll see that the outside starts to brighten up, or it starts to burn the highlights. So there's a lot of control here that anyone who's ever picked up a camera understands. So let's say if we drop down the f-stop to maybe 5.6. It opens up the lens a little bit, starts to brighten it up a little bit. So now maybe we'll drop the film speed down to 800. If we wanted to lift the blacks or maybe do some vignetting, it's going to start to darken the edges for us. So again, it uses very simple terms, things that everyone's used to seeing, and if we wanted to obviously make a very saturated image, sort of more like a digital camera as opposed to a film camera, all of these attributes are interactively tunable because of the fact that we're using the preview image.